with this question. A rectangle is a perimeter of 60 inches. What are the dimensions? Now, in class, we had a big discussion. We had a lot of different times to talk about this. But what I'm hoping you'll realize is I can't just say any two numbers. I can pick one of the numbers, but the other number is going to depend on the first number I pick. There's some calculations I'm going to have to do. I know that there are the length of two lengths plus two widths equal the perimeter of a rectangle. So you could do a lot of different things. So in class we discussed this and talked about ones that had mistakes and what they were. But I'm hoping you realize that we can't just pick any two numbers. We can't say 4 and 12 because they won't work. We need them to meet the condition of equaling 60 inches, but there are two variables that are in place. So a rectangle has a perimeter of 30 inches. Fill in the table for the missing values. So this is just to show you this is a way to organize your data. Again, using the formula that two lengths plus two widths equal the perimeter, and in this case is 30. So we have two things that are changing, and one is dependent on the other one. So if you'll push pause and try to figure this out now, that would be great, and then we'll come back to check the answer. So you try this now. On this slide, I have the answers. I kind of connected them with the colors. So you can see I have the formula, 2 length plus 2 width equals the perimeter, which they told us in the problem was 30. So it's a little different than the equations we did before because I have two variables instead of one. In the first one, I substituted 3 in for the length, and then I solved that equation for W. In this case, it was 12. In the next set, I substituted 10 in, and this time it had to go in for the width. And I had to solve to get the length. One is dependent on the other. And you can see my work for the rest of the problems here. Now we're going to use that same idea here. So I gave you an equation with two variables. So again, different than what we did in chapters 3 and 4 in that we've introduced two variables. And whatever we pick for one, the other value is going to depend on that because in an equation we are saying that the two sides are balanced and they are equal. And we need to make sure that whatever we put in for x, the y value will keep the balance of the equation. The left side and right side are still equaling the same. So you can see the numbers I'm plugging in here. If you'd like to push pause and try this yourself, you may do that. If not, I'm going to talk through this a little bit as well. So in the first one, I recopied the equation that I was given. I plugged in 0 or substituted 0 in for x. I then solved that equation to get that as long as x is 0, then y is going to be 8 sevenths. And my computer. And I did that here. In the middle one where I had y was 8, just to give you an idea and show you, you could do this for all of these, I did a check for you. So I plugged in 8 for y this time, and I solved for x. The work is here. And then to check my work, I plugged in 8 for y again, and plugged in my answer of -12 for x. And I simplified each side to make sure that I was getting equal amounts on each side, and I was. So that's good. That's kind of a way you can check to make sure that you have them all. And here are the answers as well. Okay. Okay, this one I would like you to try on your own. Substitute the number in for the correct variable and then solve for the other variable. So push pause, try that now, come back and check your answers. Okay, here are your answers. Now, one of the options I wanted to show you, and here's your work, is that you can take this and simplify that equation. You don't have to keep it exactly how it is. So you can use some of those ideas we did before with literal equations to make it just a simpler thing to work with. So what I did up here is I distributed the 4. then, because I really wasn't a big fan of this 4/5 over here, I multiplied both sides by 5. That's what's happening in this step. I multiplied both sides by 5. So when I multiply this by 5, I get 20y minus 60y equals 4, because 5 and 4/5 equals 4. And what I did is I actually used that equation to substitute my numbers in, because I felt that was a little easier for me to do. I didn't on the previous one because I felt pretty good about that one. So you have choices. You can solve an equation to make it a little easier for yourself to plug the numbers in and work with it. And again, if I go too fast, you can always push pause if you want to check your work on something. All right, over here, Mrs. Fields bought a sapling from a tree nursery and observed a linear growth of the sapling over a period of 6 months. Linear growth means that every time, if I connected every dot of the new height and the time, that it would make a line on a graph. She found the height of the sapling, h centimeters, and the time, t months, is related by the linear equation h equals 2 times 4 plus 3t. So in letter A, write an equation for t in terms of h. Does that kind of sound like what we did in chapter 4 with literal equations? I'm hoping so. For t, so write an equation for t means get t by itself in terms of h. So I took this equation right here, I distributed the 2, I subtracted 8 from both sides, and then divided both sides by 6. So right here, we're kind of still using all those ideas from chapter 3 and 4, and we're connecting them into a new unit where we have multiple variables. Then I was asked to complete a table. The numbers in black are the numbers that I was given, and the numbers in color are the numbers I solved for. So you can see as you go through here, in the first one, I was given t. And I used this formula where I solved for h because that's what I was looking for. So I plugged in 1, substituted 1 in for t, and I solved that equation. Now, in the next column over here, I had to solve for t. So you'll notice I used a different one. Did you have to? No. I'm just trying to show you the different options. So I said, you know what, I don't really want to plug t in here and do all this work. I already have an equation to solve for t. So I used that equation, that's from part A on the previous slide. I substituted 20 in for h, and I simplified to get my answer. And you can see how I alternated. If I was asked for t, I used my t equals. If I was asked for h, I used my h equals. You don't have to do that. You could have solved like we did in the previous examples. It's very much a choice of what you want to do and what you see. So in the next one, how many months until the height of the sapling is 29 centimeters? Well, how many months? I need to know t, so again, I used this equation. I plugged in 29 for the height, and I solved to get my answer. All right, in this one, we're going to go through. Here's the formula for converting Celsius and Fahrenheit. So express F in terms of C. So what they want you to do is find out what F equals by itself. So using that idea we just finished, and connecting it into our new unit. So I'm going to ask you to push pause and do that now. All right, when you do that, I multiplied both sides by 9. That's what this is saying, this first step, because I really wasn't a big fan of 5/9. So I multiplied both sides by 9, and that got me to this step. Then I distributed the 5 on the right side. Over here, I added 160 to both sides. Then I divided both sides by 5. Now remember, when you divide an expression like this by 5, you must divide each term by 5. So I have 9/5 c plus 32. So now I have an equation for F as well. Okay, and just to speed things up, the numbers in black are there. And again, you can see that I chose to use the F equals equation versus the C equals equation because it just made my life a little easier. You could have done it the other way as well. And I have the answers here for that. Oh, I guess I should have done that in reverse. So if you want, you could, do this one, try it yourself, and then come back to the video and pause here to check your answers. So what we're hoping you realize is there are many formulas where one variable is dependent on the other. And it doesn't mean we can't pick any number we want for one of the variables, but we're going to have to do some work to get to the other one. And we're going to work on that in graphing these points as well. So that is the end of understanding equations with two variables.